All right, the first slide here is a sine function. So we are going to be looking at sine functions, cosine functions, and a little bit of tan functions, and looking at their graphs. So the first one we have here is a sine function. So as you can see, it looks like a wave. So when you graph it, it takes a wave type shape. All right. Now there's some key parts to the sine function that we have to know. All right. So the first thing is we have what's called an amplitude. Okay. And the amplitude is always going to be a positive value because it is the height from the center of the wave, which you call the midline, to the top, or you can go from the center to the bottom. Okay, so that's called the amplitude. So to find it, you just need to find the middle of the wave. And how you do that is you look at the range, the highest point here, and the lowest point. Okay, and then you just add them up. Okay, and then divide it by 2, and there's you got your middle. Okay, you got your middle line, and then you can find your amplitude. Okay. Other thing you need to know is the period. The period is when it goes through one complete cycle. So if I start right here, it goes up, it's the top, that's an important point, comes back to the middle, another important point, comes to the very bottom, another important point, and then when it reaches back to that point, so there's 1, 2, 3, 4, there's 5 key points, you know it's completed the cycle, and that is called the period. And the last thing is the domain. Well, the domain is going to be infinity. We can say all real numbers. So it goes on forever, the wave. Okay, so capital R, all real. Now this slide is just for you to sort of figure out different parts of it by looking at the graph. Okay, so the characteristics. All right, so the first one I have up here is the period. So I'll put it back in the box. Now if we look at these little arrows and looking at what we just did in the previous slide, we should be able to figure out all this. So I'll just go and do the first one. That going from there to there we know is the period. So let's drag it up there and put it in the box. It says good job, I got it right. Okay, the amplitude. Well, the amplitude is going from the middle up to the top or from the middle down to the bottom. So the amplitude. Oops, not clicking on something. And I got it in the box. Good job. All right, the other thing, this black line going right through the middle is called the midline. Appropriate name. All right, and the maximum value, well, that would be at the very top. So we know that's at the very top here. And the minimum value will be the very bottom one. And I got a good job and all. Okay, topic 1, graphing sine and cosine functions. They look quite a bit alike, so you'll notice a lot of similarities. Okay, so let's just take a sketch of this graph. Okay, so the key thing you got to remember when we're doing a sine wave is it's going to look like this. So I want you to sort of reflect back to what you did in the previous guides, 5, 6, and you remember that unit circle. Well, those values are going to come into play because this wave is just like going around the circle. Okay, so I'm not going to get into too much details because we're going to spend a lot more time graphing later. Okay, the first thing, sine wave, is I know that there's no midline, but I'm just going to get some points here. That's all this is looking for. So if I go to the angle is 0, so right here, and I look under sine, all right, if I look under sine, it's 0. So I know there's a dot right there at 0. All right. Now, if I go to pi over 2, which is up here, 90 degrees, and I look under sine, I get the value 1. So 1's over here, right? So I know it's going to be 1. Right there. All right. Because this is pi, guys, I should have labeled that a little bit better. Okay, because there's 2 pi. And this line right here is half of that distance. And guess what? This line right here is half the distance that. That's why I knew this was pi over 2. Okay? And I might as well put this one in, because it's going to come up. Well, this is in between pi and 2 pi. So this is 3 pi over 2. Alright, so it's good to indicate those, because on the test when I'm marking, you have to have it labeled so I can clearly understand. Alright, so now let's go to the next one. Pi over 2 is 1, so I know that's 1. So 1 is right here, so I got that dot. Okay, pi now. Pi is over here, and sine is 0. So I come back here. Let's just use a different color so I don't get mixed up. Let's go to maybe a blue one. Okay, so the first dot, second dot, third dot. Okay. Now 3 pi over 2 is down here, so that's negative 1. Now I go down to here, negative 1. And the last one, 2 pi, back to here, is back to 0. And so if you sketch it, it looks like a wave like that. Okay? And you'll notice the same thing when you do a cos wave, but the values are going to be slightly different. So let's just not worry about sketching, let's just put in the values and then it'll be good. Okay, so we're at 0, and cos right here is 1. So now we're starting at the top here. And then pi over 2, if we go here, is 0. Okay, so we get 1, we get 0, pi is negative 1. And then 3 pi over 2 down the bottom here, you can't quite see, is 0. And 2 pi is back to 1. So you can see it takes a shape sort of like that. Okay? Now, using your calculator, we're going to graph sine x. Okay, make sure your mode is on radians because you're going to see a lot of pi's happening. Sometimes it'll be in degrees, but in this case it's going to be in radians. So calculator out. Okay, so hit your y equals, and we're going to type in sin x, close the bracket, go to Windows, and our window x is going to be 0 for our min, and for our maximum it's going to be 2 pi. Alright, and then just keep the scale at 1, go down, down, and we have negative 2 and 2. for our range. -2, enter, and 2, enter. So that's pretty good. Now let's hit graph, and there's a nice sine wave. All right, and as you recall from the last picture, you know that we went from 0 up to 1, back to 0, down to -1. So you can see that happen. Okay, next concept, example 2. We're going to talk about the vertical displacement. Okay, so the vertical displacement, and that's your D here. It's going up and down, very similar to what we did in Learning Guide 1-2. All right, so we have a sine function, that's a normal one, and if you look at the next one, we have one that is up to. So that's what I have to say, it's up to. Okay, we're not going to graph it because you'll see. And this one here, looking at the D, it's down 1. Okay, so you'll see those functions like we just did in the previous slide. It's going to be up or down. Okay. Now the amplitude is this A guy, something happening in front of the function. And we remember that back in Learning Guide 1-2 is vertical, either expansion or compression. All right. So we have a normal one, and then we have a 2 in front. So we know that is going to be vertically stretching or vertically expanding it up to. So the normal one looked like this. Okay, and we have this vertical expansion going on. We know it's going up and down, okay? So you can see it vertically expanding. Now try to determine the amplitude of each of the functions and then use the language of transformation to describe how each graph is related to these two. Well, first of all, let's look at that. That means the amplitude, I'll call A, equals 4. So there's the amplitude, 4. Now the language means it's a vertical expansion because 4 is greater than 1. Vertical expansion by 4. Okay, so let's go over to this one. Now we're looking at the cos, so this guy. Well, I'm going to deal with this guy first. Well, actually, I'll deal with the A first. The amplitude is this number of 5.5, pardon me, 0.5, or half. Okay, no negative sign. Watch out, because remember, amplitude is the distance from the center up to the top, and distance is always positive. Now, this is going to be a vertical compression by a half, or 0.5, because compression means it's less than 1. But this negative sign, which I was saying at the beginning, you have to watch out. That's a reflection. So it's a reflection on the x-axis. On the x-axis. Okay?